Hi everybody, it's Mrs. Dinkelman, and we're now in the section about calculus and vectors and some things that you'll need to know for calculus about vectors. And mostly it's pretty straightforward, and I think you'd probably be okay without watching too much. But if we have a vector that represents a position, so an x of t, y of t, then we need to know how to find the velocity vector, which is just the derivative of both components, and you leave it just like that. And then the acceleration vector, or that second derivative of that. And again, just leave those alone. And then this might be new. It's when we're asked about speed, although some people kind of guess that this works. The other way to think about this is it's really this is the magnitude of the velocity vector. If you want to add that in, you can. And it's really just Pythagorean theorem. Ooh, vector. Vectory. How about vector? I was writing velocity again. Okay, so those are kind of the main components that you need to know. And then again, this is really meant to be a self-guided tour to help you see that they're very similar. So it'll talk about parametric, and if we want to change something from parametric to a vector, we just use those two components. So that's they're very related. And then one thing I wanted to point out that is something we've talked about is just this second derivative again. So this particular problem is having you go through to prove that that second derivative in parametric mode is not just the second derivative of y over the second derivative of the x. So you're just going to pick some examples, and you can pick mine if you want, and kind of prove to yourself that it just doesn't work. You have to do that extra divide by dx dt. So other than that, just go through and again, check the solutions again as you're going through to make sure you're getting things right, and make sure that you're asking questions if you're kind of stumbling in some of those.